We learned in the previous lesson that the Henry and Brown research study indicated that neither practice worksheets or flashcards had really any substantial contribution to memorization or fact fluency. Furthermore, frequent use of timed tests was actually found to have a negative impact on student memorization. In this lesson, we're going to try to explore alternative options for developing learners who move beyond counting strategies and rote memory to become strategic learners who are fast and accurate in their knowledge of single-digit sums. The kinds of tasks that we will be exploring individually are shown here. They include tasks that are suited to training our students to derive facts and also facts that reinforce a new strategy with a practice opportunity. Although we're primarily looking at tasks that build the deriving strategy and or reinforce that strategy, we obviously aren't even going to begin to be able to derive facts if we don't have any anchor facts at our disposal. So we're going to take a look at a couple of games that can be used to develop the anchor facts for sums of 10 and doubles. Most second graders should probably know these already really well, but it's nice to have these games available so that if you encounter learners who are still building their fluency with those anchor facts, you have some options for them. We also have games that are good opportunities for practicing the new fact strategies that they're learning. The games that I mentioned in this lesson are by no means comprehensive, so I really look forward to your own contributions to the discussion board where you share some of your own ideas and links for building fact fluency that incorporates derived fact strategies. If you find learners who still need to solidify their sums of 10 or doubles, which are the two of the basic anchor facts, sets of facts that children in second grade need to know, here are some games. They're easy to do because the games are very familiar and there's just a slight twist to the rules. Go Fish and Concentration, two extremely common children's games, are usually played by searching for a pair of identical numbers. Here we tweak the rules. It's played almost essentially the same, but instead of searching for a pair of numbers, we're going to search for sums of 10. So if I have a 7, I'm going to look for the partner number. When added to 7 will make 10. The Parcheesi game, we play a Parcheesi doubles version, which is for students still learning doubles facts, and they get a die. It could be a 6-sided, 10-sided, or a 12-sided polyhedral die, and whatever they roll, they move double that amount. So they can learn their doubles very fast using this particular game. Children need a lot of practice opportunities to use their strategies, and they are more likely to use these strategies if they feel that it's a low-risk environment, that it's okay to risk trying something that feels unfamiliar and maybe doing it wrong. So games are a great way to do that. They're a low-risk environment, they're fun, they're not emotionally stressful, and so it's a good opportunity for them to practice their new strategies. Shut the Box is commercially available, and I include an image of it here because you may not recognize the name, but when you look at the picture you may actually see, oh yes, I know that one. As they find sums and flip them down, those numbers become unavailable, and so as you play, you're required to think of equivalent expressions and think of various ways you can decompose numbers. Double Compare is a game that can build fluency for addition while also incorporating some comparison and subtraction. And I have some directions for Double Compare in the Teaching Resources section, and those directions include a whole variety of levels. The image you see here is one of the more advanced levels. And there's also directions for Salute and Addition Topic. Strategy Flashcards Flash is what we're going to talk about next. In this game, children get a set of flashcards. Partners get a set of flashcards, which all suggest the same strategy. And these flashcards have been put in a set, and when the child opens up the instructions, there's a prompt to think about how to use a particular strategy. So the two partners together will go through each card in their deck, and they will talk through how to use that strategy for those particular numbers. And once they have understood how to use that strategy, then they shuffle the deck and begin to play as described on this particular slide. You're welcome to pause at any point in time. I'm going to move forward fairly quickly. The games that we were just discussing provide practice opportunities for students to apply their derived fact strategies, but we really need some instructional approaches as well to build those strategies in the first place. Although some children in our class just naturally seem to use their existing fact knowledge to derive new facts, we have many students who just probably wouldn't think to do so. We're going to take a look at each of the approaches that you see here for building and reinforcing new fact strategies. We're going to start with visual images, because if children can't see why a strategy works, they're not likely to understand it. And if they don't understand it, they will either not warm to it and just not ever use it or apply it, or alternatively, and a little more scary, they will take it as a rule and they will just apply it arbitrarily, even in situations where it doesn't apply. On this slide, you see an image of a child showing 9 figures. And I include this image to tell you a little story about the power of visual images. This story was from a situation where I was working with a first grade child, and I noticed that she really wasn't challenged by Parcheesi doubles anymore. We'd been playing with 6-sided dice, and so I got 10-sided die, and this was the first time she had been playing this game with 10-sided die. And so I was overseeing the game with these learners because of the fact they were using a new die. I wanted to make sure things were going smoothly. When this little girl rolled a 9, for just a moment, she looked a bit startled. And then she put out her hands to show 9, just like you see in this picture. And when she looked at her hands, there was just a slight pause, and then she said 18. And they always have to explain their strategies afterwards. So her explanation is right here. Well, this is 9, right? It's 5 and 4. So I know 5 doubled is 10, and 4 doubled is 8, and 10 and 8 is 18. So essentially, she herself constructed a derived fact strategy where she decomposed 9 into a 5 and a 4, doubled each of them, and then recomposed it. It was really pretty clever, and that can then be shared with the whole class, and they can decide whether they agree or disagree on whether that strategy works and try to figure out how they would justify that. Dot cards, dice images, and 10 frames are some examples of other visual images. The top image could be shown during a warm-up of quick images where it's flashed for just a moment, just long enough for students to get the visual in their head, but not long enough to count dots. And then you hide it and have them think about what they saw and how they saw it and what fact comes out of that. And then you can model writing the equations that match how they thought about it. Some examples here that I can see is somebody might see a 6 plus a 6 plus 1, and that equals 12 plus 1, so we know it's 13. But somebody else might see it as a 6 and a 3 and a 4. And so they could combine the 6 and 4 to make a 10, and that could be turned into 10 plus 3, or 13. So there's a variety of ways to do that. The tens frame cards you see in the bottom image are available from the Kentucky Center of Mathematics website. You'll find that link in the teaching resource section for this lesson. Notice how easy it is to see that 9 plus 7 is the same as 10 plus 6, because you can just imagine moving one of the hearts up to complete the top tens frame. Once students visually tell you that, I move that heart up there in my mind, and then you can actually write that down as an equation. 9 plus 7 equals 10 plus 6, and you can articulate what's actually happening. So we took one away from the 7, it turned into a 6. We gave that one to the 9, it turned into a 10. And then you can give them another one where they haven't seen the tens frames to see if they can do it. After they've had some practice opportunities with the tens frames, that is. Number talks are one of my favorite ways to foster derived fact strategies. While I used to think of basic facts work as sheer drudgery while I was growing up, number talks are actually quite enjoyable for learners. They are a low-risk environment for children to try out their budding ideas about fact strategies. And by low risk, I mean there's no grade and no teacher judgment. It's short, about 5 to 10 minutes, so it can easily fit into your daily schedule, and it's entirely driven by students' ideas. As the teacher, you provide the prompts and the task. You typically have a specific idea in mind that you hope the task will elicit, but it's up to the students to share their thinking and to reach consensus about whether something works or doesn't work. A good number talk engages everyone initially by starting out with a familiar or easy task. Because the task is easy and also a launch for strategy development, you don't have people phasing out in the beginning thinking, oh, this will be too hard for me, I can't do it. They know that they can start with that new one once they get used to these number talks. Plus, the first item that you give them is genuinely a clue for how to solve the more difficult ones. And so that allows some scaffolding for the students to tackle hard problems. The sequence suggests a particular strategy, but you need to be prepared for the fact that children come at things from a variety of ways and they won't always use the same solution, but that's actually really good because it means that you're likely to get a better student discussion going. Here you see two different number talks which come out of the Sherry Parrish book listed in the resources. In the number talk, a string of expressions is introduced one at a time. Notice how each of them start with an easy access task, as I mentioned to you just a minute ago, and then gradually gets more difficult. If you look closely, you can see that the first task isn't merely just to make the child feel good about themselves. It really does provide a clue for a successful arithmetic strategy. Once you have the idea of how to develop these number talk strings, you can create them for yourself. However, if that's intimidating to you initially, there are also some commercial resources which have a lot of these strings available, and I have them listed at the end of the lesson. After a new strategy has appeared in our classroom via a number talk, I like to follow that up with a reinforcement task. One reinforcement task that allows children to try out a new strategy in a low-risk and enjoyable setting is a game. You can modify the game instructions to suit your purposes, given whatever target strategy you have in mind. For example, Chutes and Ladders is a perennial favorite game. You can modify the instructions to turn it into a shorter and more strategic game. For example, let's say you want them to start using doubles plus or minus 1. You can suggest that they roll a die and that they can move double that amount, or double plus 1 that amount, or double minus 1. Now every roll will allow a student 3 possible moves. So if they don't like where they land with the regular one, they can either move backward or forward, depending on what would be most advantageous. For example, I'd like to get to a ladder and I want to avoid a chute. So for example, let's say that I roll a 7 on my polyhedral die. I know that 7 plus 7 is 14. But if I moved 15, I could get to a ladder. So here's the catch. In order to be able to do that, I have to state my derived fact using my anchor fact. So using this number frame, I have to say something like this. Because I know that 7 plus 7 is 14, 7 plus 8 must be 15. And then if my partners agreed that I did that correctly, then I get to move forward and take the ladder. While Henry and Brown found that practice sheets generally did not produce substantial improvement to fluency, you can modify the practice sheets to foster more strategic thinking. Instead of random facts, you can organize the facts into columns where the first column has an anchor fact that can be useful in solving the paired fact. Eventually, of course, we will want children to be able to apply that fact knowledge in random settings, but that is not the sort of thing that you do while the strategies are still in development. That's once they've been reinforced and solidified that you might occasionally try that random practice. Cued fact practice is similar to paired fact practice, except that the anchor fact isn't actually given. Rather, there's a general hint at the beginning that all of the facts on this page have some kind of a useful strategy you might think about. For example, you might say on the fact sheet that you'll turn over in a minute, you should be able to find a double hiding in the number sentence. See if you can use that hidden double to help you find the sum quickly. Now, obviously, you wouldn't say this unless you had actually modeled finding a hidden double in a number sentence and having students in a non-timed kind of a pressure try it out for themselves as well. In the past, fluency work has often happened on a completely different path from problem solving, but it's important to remember that problem solving is really the authentic application of basic fact knowledge. If you use number sets and at least some of the word problems that work well with the strategies the students are exploring, they'll have some opportunities to put those strategies to work. prompt the students before they go into word problems to be looking for opportunities to apply their strategies, to turn some of the hard facts into easier ones, and to avoid counting unless they are counting just one or two. Another great advantage of problem solving is that students can come together to share their different approaches to solving a problem. Sometimes the different approaches have to do with how they went about solving it, but often it will involve some different arithmetic strategies that are being applied. And if you are able to show that some students counted and some students used this strategy and some students used that strategy, you can emphasize in the strategy share that using those strategies was more efficient, and also validate that use of it, plus encourage other people that look at there are people who are keeping that knowledge with them, they're transferring it to this new setting that's desirable. Let's see if we can all do more of that. If you're intrigued by the idea of number talks as a way to foster strategic thinkers with a repertoire of derived fact strategies at their disposal, then you can use the ideas in this lesson, do some exploration of your own as well, and come up with your own number talks. For those of you who would like to have a little more support as you begin to try out number talks, my favorites are on this slide. I own all of these resources and I love them. The Sherry Parrish book on the upper left has many number talks at a whole variety of grade levels, K through 5. The book below it says mini lessons, but it essentially is the strings, just like the number talks that you see in the top one. And then the yellow products here off to the right are from Origo Education. The Book of Facts is a wonderful resource, and you only need that, but if you're willing to make the homemade visuals, I actually caved and went for the box of facts, because then all of the visual tools you need are already provided for you. And so I really like that resource. The Sherry Parrish book that was referenced with the number talks we saw earlier is here, and you can hear her